Welcome to Ask and Learn.
Here we have domain cannot be 1. And it cannot be negative 1. It cannot be negative 1 because the denominator cannot be 0. Intercepts 0, 0. There's no symmetry, but we do have asymptotes. We have an asymptote we have a vertical one and a slant one. Now the vertical is the easier one to find. The denominator, set it equal to 0. X equals negative 1 is our vertical. For our slant asymptote, we can solve for it by doing polynomial division. All right. Let's FOIL this out. So we have x squared plus 2x plus 1. Okay. Here we have x squared into x cubed. X times x squared would normally be x cubed, but we're going to change the sign to cancel the first term. Okay, so the first term cancels. X times 2x, switch the sign, minus 2x squared. X times 1 is going to be, and then we switch the sign, minus x. Okay, and now we have x squared into minus 2x squared, so minus 2 times x squared, bring this down, minus 2 times x squared, but switch the sign, positive 2x squared. And now negative 2 times 2x would be minus 4x. But we have to switch the sign, so positive 4x. All right, and then positive 2. Okay, and we see that this cancels out, and the next term we would have in line would be the x, but x squared has a higher power than x, so we're done with our division. We'd get a remainder, obviously, but this is the important part that we need right now. X minus 2 is our slant asymptote. And now we can look at y prime. Y prime is x squared times x plus 3 over x plus 1 cubed. Set that equal to 0. I'm going to need a bigger line than that. And we get x equals 0 and x equals negative 3. So let's say this is f prime. Negative 3. Now let's say that's 0. And remember, we have an asymptote at x equals negative 1. So let's just say it's right there. All right, so it's going to be an increasing interval here, decreasing here, and then increasing here and here, making this a maximum value, local maximum value. F of negative 3 is going to be approximately negative 6.75. So that's it for the first derivative test. And now we can look at concavity with the second derivative test. Might need to make that a little smaller. Okay. So with the second derivative test, y double prime is 6x over x plus 1 to the 4th. Set it equal to 0, and we get x equals 0. Put that in our second derivative test. 0, and we see that it's concave down here, concave up here, making this an inflection point. Okay, so that's it for concavity. I made this really small because this graph is going to take up some space. All right, let's make some more room. All right, this is our original function. Let's move that over here. I'll circle in red or in blue our original function. Okay. To make more room for the graph, it's mostly going to be down here, so all right, we have an intercept at 0, 0. Next, we can put our asymptotes at -1. X is -1. And we have a slant one at y equals x minus 2. So if we say that this is 2, 1, 2, and this is 1, 2, then we have a slant asymptote going through here. All right. And now we know that we have a minimum at -3, -6.75. So let's just say this is -3, -6.75. And we know it's going to be like this because it is a local maximum. It has a curvature to it. Difficult to draw, but there's a curve. All right. Okay, and next we have our now how does the graph approach our intercept? Well, we know that it's going to be concave down before it reaches 0. So it's going to be down, 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 approaching but never touching the asymptote. And then it's going to come up to 0. And then it's going to be concave up the rest of the way and approach but never touch our asymptote.